Alright, welcome back. Today we're going to learn about for loops. We're going to find that they're very useful. So let's jump right into this. Switch screens here. There we go. You'll notice I've got another little camera going here. I thought this would be quite useful for future videos, so you can kind of see what I've built instead of using Tinkercad the entire time and me trying to hold it up in front of the camera. I can have it sitting here under this view, and I think that'll look, hopefully that'll add make it a little easier for both of us. This build though, I'm going to use any special parts on the Arduino, so next time we'll be using that. I'm going to leave it up there just for habit. I'll shrink it down a little bit, get it out of the way, and let's make the print a little bit bigger, which I need to do in here just a little bit, go a little bit more. And it says Control plus, but the one plus doesn't work. The other plus does over here. Alright. That looks like it'll be big enough for you to see. Nice and easy. Alright, so there's the basic layout in our IDE when we set it up. Arduino is already plugged in. And so I'm just going to check the ports already looking good. COM19. It's got the right board. I got to make sure it does that. Just automatic when I open up this IDE, or after I plugged in my Arduino. And the build today, as I mentioned, is for loops, which is basically loops inside of a loop. And I'll talk about that as we start to construct something. Our project we're going to base for loops around is simply just quite simple. We're just going to have make a little stopwatch. And in order to be able to see the stopwatch, first thing we're going to do is open up the serial monitor. So let's do that. We've done this before. Anytime we want to come over here and use our serial monitor so we can see what our program is doing, we need to make sure we have this statement up. The 9600 is the baud rate, which is kind of the default rate, and we know we can change that. And let's jump down here. Let's put a for loop in here right off the bat. So here's a statement. It changes colors. So we know the computer recognizes what a for means. And we're going to have some parentheses. And we know whenever we generally see parentheses, we're expecting, for example, digital write. We might have pin 8 high. So we have what's called parameters we're putting inside of this statement. In this case, we have the pin number and whether we want to turn it on or off. And this is pretty simple. We put a little comma between the two parameters. Here we're kind of doing the same thing. Now, we're not going to actually put this in our program. I just want to contrast it. So inside of here, we actually have 3 parameters. Here, this one has 2. Another example of one would be delay, say delay 100, which is of course in milliseconds. We have 1 parameter putting inside of our parentheses. Now let's go back. I'm going to leave these up here just for a minute, just for contrast, and I'll get rid of it. So we have 3 parameters. The first one is where we need to set up some sort of variable that we're going to be using in our for loop. So I'm just going to use x. So since I can't just write x equals 1 because it doesn't know what x is. So I have to, it knows what for means, it knows what digital write means, it changes color, but x, it's not going to know what that is. So I have to use a data type. And we're going to be counting, so int will work. And we'll just start with equaling 1 right now, but we can always change this. Now typically we would put a comma, but in our for loop we have to make sure we put a semicolon. I mess this up all the time, so I'm very used to putting commas in here. But in the for loops we want semicolons. So here's our first parameter, first bit of information that our for loop needs. Just a little starting point, what's this variable that I'm working with. And then the next little chunk is a starting place, or actually this is our little statement where if true we're going to stay in our loop. our for loop, and if it's false, we're going to get kicked out. I'll give you an example. A lot of this will make sense after we built a little program. So let's say x is less than 10. That looks pretty good. So if whenever x is less than 10, we're going to stay in our for loop. Whenever it's not, we're going to jump out of it. And the last thing is we need a way to change the value of x. If it's x at this point stays looking at 1, which is always going to be less than 10, we'll never get out of our for loop. We'll always be stuck in this little sub loop. So we need a way to change x as we go through the for loop. So we're going to say x equals x plus 1. Now you might think we need a semicolon at the end, but we actually don't. So here's a little comparison. I should add one more thing here. We're going to have opening and closing brackets right here and here, because when we're stuck in this loop, we need to know what part of that loop is part of the for statement, and that's going to be described by putting this opening and closing bracket. So that kind of contrasts a for statement versus a digital write and a delay. We have 3 parameters, 2 in here and 1 here. We're using commas here, semicolons here to break up the different pieces. So I'm going to get rid of this. That was just a contrast right there. Okay, so for loops are really nice because for just, prior to this, we were just using the loop, and as we had different statements in here, we'd go from one to the other to the next one just in order. But oftentimes it's kind of nice to be able to stop somewhere in our loop and say, hey, I don't want this to be done just one time. I would like you to actually repeat yourself 3 times or 10 times or whatever, and then go on to the next thing. So as you're going through the loop, I want you to just pause and do this statement 5 times or whatever, and then continue on, and ultimately go back to the start and repeat yourself over and over again. But so let's take a look and see how that works, because we wanted to just do a little counting for this one. So right now we're going to start out at x equals 1. As long as x is less than 10, we're going to stay in this little loop, and then each time we go through the loop one time, we're going to actually increase the value of x by 1. So next time we go through the loop, x will equal 2, and it'll check to see if it's still less than 10. If it is, it'll just keep going around and around. Now right now there's nothing in here, nothing for it to do. So let's give it a job to do. I'm just going to have a little fun here. Let's say serial print. Actually, let's not do that. I was going to do something silly, but let's do help. I am stuck in the for loop. I actually do something similar to this. If I'm writing some heavier code and I'm just trying to do a little experiment to see what's happening in my code, I'll do things like have it print something to see if it actually got in the for loop, or if it's stuck in there, or kind of give me some feedback that I can see in my serial monitor. So once it gets in this loop, it's going to print help. I am stuck in the for loop. That's not what we really wanted to accomplish. We wanted, of course, have it do some counting. So let's go ahead and have it do that. We're going to have it serial print again. And this time I'm not going to put the ln in here. Remember, the ln means that after I make this statement, put this statement into the serial monitor, I'm going to jump to the next line. I'm going to jump to the next line. This time I don't want to jump to the next line because I'm going to have it print out the variable x first, and then I'm going to have it go to this other line, give it a little space, and write seconds. Maybe leave that off like this. So what's going to happen here is after it prints this out, it's going to jump to the next line, which is to print the value of x, which we know is 1. And then it's going to put that in the serial monitor, not jump to another line, and then it's immediately going to print seconds after that with a little space here. So it'll be the number, little gap, and then seconds on the same line, and then it's going to jump to another line. So I think that'll look nice. Let's say I just upload this and see what happens. Wants me to save it. I recommend you actually type in a name when you hit save. I do so many of these I'm in the habit of just putting it defaults with the date. But I've had a lot of students ask me about their code they're working on, and they want to save it. Well, there's your opportunity to save it. If you're using the Windows Store version of this IDE, you should be able to save it in Arduino folder in somewhere on the laptops. This PC, I think there's a place called This PC. I don't have a laptop in front of me. Of course, you can always ask me, but it does store it on your computer so you can look at it later. Okay, we just wanted to take a peek at this, see what we've got. And we got a bit of chaos here. We're running through this so fast that we can't really tell what we've got. We got a sense that it seems to be looking kind of nice. A couple things to point out. Right down here in my serial monitor, where my forehead is, it says 9600 baud. I had to make sure that matched the 9600 up here. I have other selections. If you get an error, it might be because of that. We don't have an error because of that, but it's the default is 9600 baud. And in a prior video, we talked about briefly this no line ending as an error. I won't go back into that until it happens again, but there's some options here for when we're waiting for some user input. Sometimes we get a little error. We need to switch from no line to new line. Just a reminder of that. So let's clean this up though. It's just going too fast, so we need to slow it down so mere mortals like myself can actually see what's going on. Let's do, well, it's supposed to be a counter, a stopwatch. So let's actually make it 1000. So a seconds here, the delay being actually 1 second. That would make sense. Let's go back and look at it again. Re-upload it. That looks pretty good. Alright, now we're counting up 1 second. And we get to, let's pause it here. Once we got to 9 seconds, notice that we didn't get to actually 10 seconds before we jump back to 1. So we're in this thing repeating it over and over again, going this line, it's printing that out, then it's printing what I just told it to do here with the current X values, and then second right at that, my little gap, a gap being right there, a couple spaces I put in, waiting that 1 second. Technically it's probably not 1 second, it's probably just slightly, because it's got to take some more time to go through the loop, but it's good enough for us. And then of course it's increasing the value of X each time by 1 until it gets to 10. Now when it's 10, I told it X needed to be less than 10 before it gets kicked out. So at 9 it's still a true statement. As long as this is true, this parameter right here, then we're going to stay in this little mini loop. Once we hit 10, then we're kicked out and we'll jump to another statement right out here. So let's try that out and see if that actually happens. Let's put a serial print. Let's put some LNs in there so we get a lot of space. And let's say I am something positive. Yes, I am not in the loop. You can put whatever you want in here. Just being a little silly. But mostly I'm just checking. I'm using this as another troubleshooting tool to demonstrate exactly how this for loop works. So after I'm even going to put a little space in here. And another LN, so it'll jump down a little bit, get some gaps going, get some little lines and little separation between all these little words we're going to have coming up on our serial monitor. Alright, so when it jumps out, it'll say, yes, I am not in the loop anymore. And if we don't put a delay right here, it's going to immediately go back to the top and start counting again. It might go so fast that we won't even see those words. So let's put a 5-second delay in there. Alright, so 5 seconds is going to sit and wait, and we'll see this, and then it'll jump back and start repeating this loop. So let's check it out, see it in action. Alright, that's good. It's fast. Alright, help, I'm stuck in the loop. We're counting 1 second, 2 seconds, 3 seconds, so on, all the way up to 9. And then yes, I'm not in the loop anymore, and it's kind of waiting for 5 seconds. Big gap there. Now we're back in, stuck in the loop, and we're going around and around and around. Alright, so let's change things around a little bit. Toy with this. What would we do if you wanted to count, say, up to 5 and include 5? So not up to 4 and then be kicked out, but count up to 5, and then we'll see 5 included, and then it kicks itself out. How would we sort that out? So take a moment, fix the code, stop the video, make a little adjustment, see what you would do. I'm just going to go ahead and do it. I assume you stop the video. I want it to go to 5, so I'm going to shrink that down to 5, and I want it to include 5, so I need to put a equal sign in here. So let's upload that and see if that solved that little mini problem for you. It's kind of interesting down here, the information. I don't know if you ever read this before. The size of our sketch. This is our sketch. Our program is 1,852 bytes, or 1.8 kilobytes. And the total amount of memory on our Arduino is 32,256 bytes, or 32 kilobytes. So you're used, this tiny little bit is used up 5% of the available space. Anyway, I thought I would throw that out there. It's kind of interesting to see how big your program is compared to the amount of space available. Alright, let's take a look. Going 1, 2, 3, 4, 5. There it is. So included 5. It's waiting the 5 seconds. And now it's starting over. Alright, looks good. What would we do if we throw a couple more at you here? Let's say I wanted to go to 100 and I wanted to count by 5s. What would I do with that? How would I want to start at, let's say I start at just where I'm at, and my increments are not 1, then 2, then 3, but we go 5, then 10, then 15, then 20. How would I do that? Pause the video and alter your code a little bit, see if you can figure that out. I'm going to go ahead and do that, assuming that you've solved this, or made an attempt at least. Since I mentioned you want to go to 100, we need to move this and make it 100. And we want to count by 5s, so we're going to put a 5 here. I like little gaps in between things, makes it easier to see what's going on. Now we're starting at 1, so the first x is going to be 1, and we're going to add 5 to it. So if I go around, and if I just did this, I should end up with 6. And not 5, 10, 15, 20. I want to verify this. It's always kind of fun. We can quickly get an idea and verify it. And there it is, 1, 6, 11, 16, which is not what I wanted. So how do we fix that? I didn't want to start at 1 and then add 5 to that. I wanted to start at 0 and add 5 to that number. So let's take a look at that. See if that fixes the problem. Okay. Now we're at 0, 5, 10, 15, 20. That looks fabulous. And then when we get to 100, it'll include 100, Then we'll jump out of the loop and we'll wait our 5 seconds. Let's just pause a moment and watch it do that. Nice. So it's waiting. We're out of the loop. Now we're down here. It's reading this. Now we're on delay for 5 seconds. Now let's jump back to the beginning here, and it's working its way through again. Okay, let's do maybe one more thing. What if I wanted to start at a negative value? Maybe minus 100, and I wanted to go to 0. And I'm counting by 5s. What would I do then? I'm going to end at 0. I'm going to start at minus 100. I'm going to count by 5s. Pause the video. I'm going to continue with the solution here. So we can put in minus 100. We want to count by 5, so we want to keep this the way it is. We want it to end when, remember this statement is, as long as it's true, we'll keep in the loop, but once it becomes false, then we'll get kicked out. So we're going to just shift this to being 0. As long as x is less than or equal to 0, we'll stay in this little loop. So let's check it out. I think this will work. Alright, now we're counting down. Now this really isn't a code issue, it's more of a using some of the math you've learned in actual application. You're wondering when you'll ever use some of this stuff you learned in your math class. Well, here we're using some of it. And to 0, starting over, out of the loop, and so on. We won't wait for that. And then we could go on and on with this. What if I wanted to start at, say, 100 and count backwards by even numbers? I wanted to go backwards by even numbers. What would I do? Give you 2 seconds to pause the video. Start 100, go backwards, counting by zeros. Now this is going to be a little more challenging because of this statement right here. We'll have to segment it or capture the two maximums and minimums. So let's go over here. We want to do the minus 2, and we wanted to start out at 100. So as long as x is less than or equal to 100, it'll stay in the loop. Now if I just leave it like this, we're going to just, we'll never exit the loop. We'll just, actually let's just do a little experiment. We'll pause right here, see what happens. So we started at 100 and we're counting down the even numbers, 98, 96, 94, so that looks great. Except x is always going to be less than or equal to 100. So we're always going to be stuck in this loop and we'll never get out. So we need like another statement that says an end in here. Whoop, that's not an end. That's an end. So x is less than or equal to 100 and x is greater than, say, I don't know, let's just do a little experiment here. Do 90, see what happens. Let's just try it out. Some of this stuff I'm just trying out for the first time, and I'm like, I gotta figure out in my own head exactly how to do it. So there's that 5% of, do I really know what I'm doing? Am I going to figure this out correctly? Anyway, it looks good. I didn't include the equal sign, but I didn't want to drop it all the way down to 0 and I have to wait for it. So we have both these statements, and of course this one fails, becomes false when we're at 90, and so then we jump out and we're into this, yes, I am not in the loop anymore. Alright, so that's probably plenty of practice. Now we're going to use it later in not printing things out or counting. I mean, this is cool and everything, but we're actually going to get it to control something, and we want to get stuck, purposefully stuck in a loop, and we'll talk more about that later. I think I actually want to show you one more thing though for some of my advanced students, and this is another way of looking at the structure of your entire sketch here, this entire program. We just looked at a chunk here called void setup, where things happen at the beginning. Down here is the loop where we work our way down, and then when we get to the bottom we go back to the start. So we have opening and closing brackets as we're moving down and jump back to the start. And then the purpose of this lesson was to, as we go work our way through the loop, we can go into a little mini loop and stay in that for a little while, and then jump down to the next statement, and so on. But there's a couple more things. I don't know how much we'll explore this in the future, but I just wanted to point this out. Another way to think about the structure of our sketch. It's a little more fluid than it looks like. Up to now, we've kind of been using the same basic structure, but I can do something like this. This as an example. I can make a separate function under setup. I can call it, say, example, and down here I can call it let's do this, void example, and let's just build that just for a moment. So what I've got here is a way that I can compartmentalize my little pieces of my program. So actually I'm going to have a bracket problem. I'm just scanning here. Let me just double check. This is a nice little trick. If I click next to a bracket, okay, that's my opening and closing for my loop. I just noticed I had 2 down here. Like, why do I need 2 there? I'll just get rid of that just for a moment. If I get an error, we'll track it down. So I've got a separate little void thing going on here. I titled it example, and I can put some its own independent chunk of code. Man, I can't talk today. And in this example, let's just be a little brief with it. This is kind of just a little intro to get you kind of. I don't want to make you think that this structure is absolute. It's a little bit more fluid than that. I'm going to just throw in here a quick example. Let's do ln again. And let's do, I don't know, something simple to say. Let's start counting. And we'll delay. Let's go along with that so I know it's actually staying in there. Alright, so in this little chunk, this little function down here, I've got a couple statements. The first one is, let's start counting. This is going to print that in the serial monitor, which I've already turned on in the setup. And then we're going to just wait for 5 seconds. Alright, so what's going on here, Mr. Brower? You're confusing me. Let me just clean this up so you can see everything all. Get rid of some of these little spaces so we can see it all together here. Close the gaps. Mind the gaps. We got a couple at the top up here. One more. And let's shrink it down just slightly. Alright, basically we can see it all on here. Oop, and then I flicked it, now we can't. There we go. Alright, so under void setup, it's going to start here like normal, and it's going to turn on that serial monitor, but then when it sees this, it's going to say, hey, you want me to jump down to this other little piece of code, this other function, and then run it. And then once it's done, then I'm going to jump down and do this other little piece of code. So basically we can send our what we want to have done into actually different directions, and have within those new directions, and we can bifurcate and say, no, go down this route for a minute, do this loop thing for a while, and then when you're done, come back and then head off in this other direction. So as not to be confusing, let's finish off what we've got here, and then we'll call it a day. So it's going to jump down here because it's going to go in order, but it's going to jump down to this. It's just called the call up. It's saying, hey, you want me to, this is what I built this one. I just called it example, and it should jump down here and print let's start counting, wait 5 seconds, and then it's going to go back to void loop and do what we already saw. Let's upload that, give it a try. Okay, and there we go. Let's start counting. So it jumped to this, waited 5 seconds. Now, since it's finished with that, it's going to continue its way down and going to void loop and doing all this counting stuff. Now we just jumped out, and we're kind of right now stuck in this void loop. It's going to keep going around and around and around forever. But I just wanted to give you the idea that we can, I think the technical term is to make it modular. We can have little chunks of code. Sometimes it makes it easier to build a little piece of code that performs a certain task, is what I'm trying to say. And then we can call it up. It will jump to that and perform that little function, and then it'll go on and continue with some other little piece of code. So we'll toy with this a little later. Right now, don't worry so much about that. Our goal was the for loop. So I think we did a good job with that, and that'll be it for today. So let's call it a day. We'll see you later.